Hello, welcome everyone to this class. I'm going to be solving this question on gravitational field. All right. So let's look at the question. It says a planet has mass m1 and is at a distance r1 from the sun. A second planet has mass m2, which is 10 of the m1, and is at a distance of r2, which is 2r1 from the sun. Determine the gravitational forces experienced by the planet. And this is Jamb 1997, but it doesn't matter the age or the year. Let's just do it one before the other. It's going to be very interesting. Look at what I'm going to do. Since I'm looking for the ratio, it simply means that I'm going to have either the gravitational force F1 all over F2, or I'm going to find the F2 all over F1, because they did not tell me the ratio of the first force and the second force. All right. What do I mean by this force? I'm talking about the gravitational force. So what is force in general? The gravitational force is given as Fg ms. So we have the gravitational force, which is G, which is the gravitational constant, mass of the sun times mass of the planet 1 all over the distance. Okay, let me just put it this way: m2, m1, and the distance separating the two. What I mean is this: if this is the sun and this is the planet, right? So this is the sun and this is the planet m1. The distance separating them is given as this r, and there is a force of attraction between them, and that is what this force is all about. So what I'm going to do right now is, for every of these m, I'm going to have either m1 or m2. All right, so this is the formula I'm going to use to do this. So let's go for the F1, and I will do for the F2. F1 is going to be, for the F1, I'm going to be choosing M1 and R1. So I'm going to say that F1 is going to be equal to G, which is the gravitational constant, and mass of the sun is going to be my M2, and then M1, which is the mass of the first planet, all over the distance separating the sun and the planet, which is going to be given as R1. This is my first equation. So the second equation is going to be F2, which is going to be the same gravitational constant, the mass of the sun, ms, times the mass of the second planet. But remember, the mass of the second planet is given as 10 times the mass of the first planet. So I'm going to remove m2 and put 10m1 in multiplication. All over the distance separating the two, the sun and the second planet, is given as r2, which is given as 2 times the distance of the first planet. So I'm going to have 2r1 all squared. Remember, this one should also be squared. All right, so at this point, I'm going to take this all over this, and I'm going to say this implies that G ms m1 all over r1 squared divided by the second one, which is going to be 10 G ms m1 all over. When I square this, 2 will be squared and r1 will be squared. I'm going to have 4r1 squared. So according to the fraction, I'm going to remove this divisional sign, carry this up, and bring the numerator down. So I'm going to have G ms m, mass of the m1, mass of the planet 1 all over r1 squared times 4r1 squared all over 10G, mass of the sun and mass of the planet 1. So remember, Gms m1 is going to cancel with this one. Then r square, you're also going to carry with this r square. So I'm having that. I'm doing F1 over F2. Therefore, F1 all over F2 is given as what? 4 over 10, which is 4 divided by 10, which is something as 2 over 5. So the ratio of the first planet with the second planet is 2 over 5, or 2:5, which means that the ratio of the second planet with the first planet is going to be 5 over 2, or 5:2. Thank you for being part of this lesson. Remember, the right thing to do is to hit the subscribe button, share this video, and like and comment.